Yeah. So in terms of salary and CTCs, a fresher who's entering into EV can expect somewhere around 6 to 12 lakhs per annum as a CTC, right? Based on the role he comes, right? Usually I've seen that embedded firmware engineers or embedded hardware, electrical electronics CS side gets more chunk as compared to the mechanical engineers, right? In beginning as well as they move forward. Coming to the roles which are for the experienced roles. So if you're working in a traditional company, EV is usually there are a lot of startups in EV, right? So a startup usually gives you a good, like say 30% more salary as compared to your existing what do you say, pay scale in a conventional MNC company. And there's a rule which I'll share, like which lot of companies follows for this CTC, deciding the CTC. It's usually for a non-startup company 2 to 3 lakhs per annum and 3 to 4 lakhs per annum for per annum of experience for experienced company. What I mean to say, let's say you are a 6 years of experience, right? So if you're a 6 years of experience and you're going to a established company or MNC company, so 6 into 2 or 6 into 3, what is that bracket? 6 into 12 or 6 into 3, 18. So your CTC will lie somewhere between 12 to 18 lakhs per annum.
With 6 years of experience?
Yes.
In the relevant domain. Like with EV, if I am from the EV space, if I have 6 years of experience, I will have this much back.
Similar domain, not necessarily EV, but your experience will be considered, right? Same, just same domain will help you more, right? And let's say with 6 years of experience, you're entering into the startup, it's usually 3 to 4 lakhs per annum. That is 6 into 3, 18, 6 into 4, 24. So your CTC should be somewhere around 18 to 24 lakhs per annum.
Got it. Okay.
This rule is going to, disappoint a lot of HR people.
Hello everyone, welcome back to yet another episode of Intellipaat Talks. Today in this episode, we're going to talk about how you can make a career in the EV industry. And to discuss that, we have a very special guest today. We have Mr. Bhanu with us, who is an EV engineer, right? So we are going to learn a lot of things in this podcast, including the fact that how you can basically get into the EV industry. So guys, let's get started. I'll see you in the podcast. Alright, so hi Bhanu, I've already introduced you to the audience, but can you give us a brief introduction about yourself, like who you are, what do you do, and then we'll take it forward from there.
Yeah, I'm Bhanu Marwaha and I work as lead engineer of charging infrastructure and battery at Simple Energy. In Simple Energy, we have created a scooter called Simple One, which is trying to revolutionize the way our country moves, use the EVs, right? We are trying to accelerate the adoption of electric vehicle through innovative technologies incorporating into the EV. Here I am trying to share my insights of my almost 10 years of journey into the EV industry, what skills you may need in this industry, how you can navigate in this industry. I'm very excited to share my insights. Thanks a lot to Intellipaat team for giving me the opportunity to share my experience with you.
So yeah. I want to know, okay, we have suggested people what to do, but I'm sure when you were studying, you didn't have in mind that I'll make a career in EV.
Yeah.
Right? So how did it start for you? Let's start from your school. What were your interests? How that developed into where you went in college? And then how did you decide that, okay, my career has to be in the EV space?
Yeah, so my entry into EV has been a bit interesting one because I always, I had in my school time, I had a knack for this engines, right? Gasoline engines. I used to study on gasoline engines, the petrol engines, how did they work? And I wanted to join any university as a mechanical engineer. But unfortunately, my marks were not up to that, the entry, whatever. So mechanical engineers need higher cutoff marks as compared to electrical.
For doing what?
For engineering.
Okay.
Right. So I was very much, you can say, depressed or, that I got electrical. I couldn't get mechanical, right? And I always wanted to work on vehicles. So the only way to work on vehicles by being in electrical engineering is through electric vehicles.
Wow, okay.
So that's how I decided to.
Okay, then I think it was destiny for you because you knew firsthand that you had interest in vehicles.
I wanted to work in vehicles, and the only way it could have happened. Let's say if I would have got chemical engineering, I would have worked on fuel cell cars. I would have been giving you podcast on fuel cell then.
Okay.
Yeah.
So then how did you pave your way? So you knew you had to work on vehicles. You got into electronics. Then what happened? Like what did you do?
I joined a society for, we had a lot of clubs in our college which used to work on different.
Which college are you from?
I graduated from Thapar University, Patiala.
Oh wow, okay.
Yeah, so there were a lot of clubs and societies inside our university which used to work on different technologies and all those things, right? So there was one team which used to work on electric cars.
Okay.
So I joined that team, and 2 years I worked in that team, but somehow I'll say due to leadership issues of that team, we were unable to roll out the electric vehicle.
Okay.
And I was frustrated, like I used to do my work okay. If others are not doing, why should I suffer, right?
Typical college group. Yeah.
So then I started my own team. It's called Team Oorja, right? Where we manufactured a solar electric car. It used to charge from sun and it used to drive, right?
Oh wow. Okay.
And
so how much time it took to charge that car?
so it used to take around 6 to 8 hours to charge that car.
And how long can you drive it?
So 30 to 40 kilometers we used to drive.
Wow.
But
That's amazing.
It
Out of nothing, you're able to drive 30
Yeah.
to 40 kilometers. Yeah.
Yes, we had a solar panel on that. We went to a competition. We won that competition.
Amazing.
And then we built that team bigger, right? So I founded that team. After that, we got funding from University of Waterloo, and we still built 2 electric cars every year, and with a new technology.
So that team is still going on?
Yeah, it's still going on.
So, like, you are the core members. So now people from college are there in your,
yes.
how does it work?
Yes. So as a founder, I just started a team, and after that, I set a system of how next captain will come, right? And just started gave them a framework for the team, and it's still running. I don't work just involved in their day-to-day operations, but they're.
You set the vision for them.
Yeah, I set the vision for them. Yeah.
Okay. Then how did you transition into the EV career?
Yeah, so after that, my first industrial exposure was with ISRO, where I worked as a trainee engineer.
Okay.
I had, I'll say, one of my most lucky days was there. Had an opportunity to work on some interesting projects, right?
Did you work on the Mars project as well?
Something related to satellite I worked.
Oh, wow.
Right?
Okay.
So
is it there right
Yeah.
now? That's satellite? Wow. Okay. Amazing.
So it was, So that's where, I got a lot of passion. I got to know more about electronics.
Right.
And then I got an opportunity how to use that space-like safe technologies into EV. Because like in any space project, you need safety, right? You don't want your rocket to burst, or you need safety everywhere.
A lot of money is also involved.
Money is involved. So that safety, I thought, let's use it in EVs. Let's try to make safe EVs, right? So after that, I worked in Asian Paints Limited for 2 years, where I worked on robots, automation, and AGVs, where we had automated vehicles, electric vehicles, automated guided vehicles. That used to work in factory area and all. Worked in renewable, so our plants were powered by solar and renewable, solar energy, wind energy. So got a exposure to those fields. Then I started my startup, founded my startup, where we wanted to create a lithium-ion e-rickshaw, which is user friendly, which adds value to the user, and we came up with a new design and concept, right? So 2 years I worked there. We had a team, we had an office, we started some sort of manufacturing. And then I worked with the Ion Energy. It's a BMS company, right? We used to manufacture battery management system for a lot of companies. Then worked with Integrate Technology, which is a battery manufacturing company, right? It's where we use some Japanese cells to create very safe batteries. And now I'm working with Simple Energy for last almost 2 years, right? So try to involve, whatever I learned in terms of safety, performance from these different exposures into the scooter which we are building.
So it was a very organic journey for you then, because when you start from ISRO, you don't have it in mind that I have to get into the EV space. But because you had that passion for vehicles, I think you took those actions which were coming to you, which made you come to where you are right now.
So, that you can say it's love of my life. It pulled me.
I mean, that's everyone's dream to, work in a profile or work in a way where you can also align your passion.
Yeah.
So that's amazing. Yeah. So pleasure is all ours, Bhanu, first of all. So thank you for giving us time for this podcast today. So Bhanu, there are a lot of questions that I want to ask. So first question that I want to start with and set the baseline for this podcast is like, we've all been hearing about EV since a long time, right? But it has come into reality, I think, since the past 5-6 years. So can you tell us, like, where was EV from the starting, and like why are we here today? Why is the EV technology, it took so many years, like EV, if I go by white papers, EV was there in 1970s and maybe before that also, right? But why is there a breakthrough in this decade? Right. So if you can just shed a light on that.
That's actually a very interesting question, because it will shed a lot light on how this industry is evolving.
Right.
So the thing is, one of the thing which most of people get confused, the first car was not an IC engine car. It was actually an electric car.
All right.
Right.
So by IC, can you just...
it's a internal combustion vehicle. Petrol, gasoline vehicles.
All right, yeah.
So the first vehicles in road were EVs, were electric vehicles. Then the shift happened to the gasoline engines, and then again the shift is happening into electric vehicles.
All right, okay.
Now we need to understand why those shifts happened. So the first cars which were electric taxis, which were electric vehicles, were used for the intercity commute.
Okay.
And there you don't need much range. You don't need much charging time.
And which year are we talking about?
We are talking about almost, let's say, 18th century, somewhere around that. A very, I'm going very back in time, right?
Okay.
At that time, we had a very fancy looking electric city taxis. If you'll just Google electric city taxis in 18th century or 19th century, you will get a lot of images on Google, which will show you those fancy looking cars were used for an intercity commute, right? So at that time, those cars were electric, right? And then suddenly a shift happened to the IC engine vehicle. Because of one reason, that in electric car at that time, we don't had the battery technology. At that time, the battery was lead acid batteries. And that couldn't take a person outskirts of a particular city, right?
Range was less,
right? For example, if I talk about the city for Bangalore, right? If I have to use electric car of that time, I could only travel intercity, right?
Okay.
And then always there was a need to go for a longer commute. And that's when the gasoline engines evolved. And that's when Ford actually revolutionized that thing, and Ford's Model T was launched, which was the first commercially successful gasoline vehicle, which people used to take to, for commutes outside the city for longer range.
And this is which year again?
Again, it is, let's say, you can say 50 years after that. We are talking.
So maybe 1950s or 60s. Okay.
What we are talking is in the context of last 150 years, 100 to 150 years, right? Now you see the shift here. What happened was, in case of the cars, was from electric to gasoline. But if you see in the shift on trains, it was opposite. Right. The shift happened from steam engine to electric trails, right?
In that same time period.
Yes, in that same time period.
Right.
So it was everything got twisted, right? Reason why it happened in case of electric trains, because electric trains didn't need battery. They could drive on the rails, which was a continuous power supply.
Right.
So the problem statement why EVs couldn't take off at that time was where to store energy, right? How to go long distance, right? There we didn't have the battery technology. In case of electric trains, how it could be solved? Because there were rails. But you can't put rails on the cars. You can't define the scope of travel for a car, right?
Correct.
So that's when these two shifts happened. So from this example, we can understand that in terms of efficiency, in terms of performance, EVs were always better, even 150 years back. It's just due to the range issue. It's just due to the battery issue. How to store the energy. How to store energy in an effective way, right? So even for 50 kilometers of travel, we needed a big, boot space for battery at that time, right? So that was the challenges, and that's how now we are able to solve this challenge due to the
So what
battery
happened when, so you said that Ford revolutionized EV cars, right?
Yes,
In
sir.
1960s or 70s. So what change did they bring? Like feature wise, what was new?
So why did Ford was able to successfully commercialize the combustion engine vehicles? Because they worked on the engine technology so that it's easy for the user to adapt, right?
Okay.
In the sense, earlier there were a lot of effort to crank the engine, and even a lot of people would have seen in the autos, if auto stops, a auto driver will have to pull up like this, right? So it was not very user friendly at that time. So Ford was able to make it user friendly through some of the engineering improvements where they could easily start the vehicle. So that's how Ford was able to take off that shift to electric to IC.
So because of Ford, the IC engines became so popular.
And then the IC engine revolution started.
Because the range problem was solved.
Yes, the range problem was solved.
Okay.
And in electric trains, the opposite happened. You had direct power rails, so you could change from steam engines to electric trains.
Right.
Now coming back to the point, the question you asked, in 1900s, General Motors launched a vehicle called EV1, which was fairly commercially successful vehicle, right? Which had good range, which could be commercialized, but it actually recalled those vehicles and put it in scrap.
Okay.
It's a So it's a very interesting thing. If you just Google the images GM EV1, you will see the images of a scrap house where they recalled the vehicles and put to scrap, even though that vehicle was successful. And now suddenly everyone is saying EV, right?
So why did that happen?
Yeah, because climate change was that time also.
Okay.
People think it is due to the climate change. It's not due to the climate change. So for that, we need to understand the economics of time of that 1900 period which I'm talking. So this is the time of, let's say, 1990s I'm talking about, when GM launched this EV1 vehicle. At that time, there were three industries which were very prominently giving GDP or tax to the government, right? One is the oil industry, right? Other is the service industry. And third is the IC engine industry as a whole, right?
Okay.
So if the shift would have happened to the EV, there would have been loss in terms of taxation to the government for the oils,
Right.
oil bills, in terms of service, because EV doesn't need service. EV has a very fewer mechanical parts. EV doesn't have so much parts, right? So it doesn't need that much service. So loss to the service industry, and mind you, dealerships earn more from service rather than from selling the vehicles. And third, the companies had invested a lot in the manufacturing lines of the vehicles. So if they shifted to EV, those investments would have gone. Once you set up a manufacturing plant, it runs for years and years.
Right.
So this was the scenario 1990s.
Okay.
But then suddenly this shift has happened after 2000. So I'll just give you an opportunity, like you can just guess what would have happened, or I will just give a audience a chance what would have happened after 1990s. Why again we are coming to EV?
So I'm assuming this is about the US politics that we're discussing, right?
Yeah.
Maybe pressure on government for them to do any action on climate change.
So frankly, I believe that these pressures never worked to the government.
Okay.
They are more concerned about the economics of the country.
Right. So what changed?
So we see after 2000 a new revolution came into the market, which was software revolution, right?
Okay, yeah.
So major chunk of GDP has now shifted to the software companies after the 2000s. These companies are paying a lot to the government. They are giving a lot of profit to the government. They don't need that much manufacturing space, and they have a competitive edge. They can, scale easily, right? So what most of the governments are trying to do is push software into most of the fields, right? So software into agriculture, let's say software into the phone, software everywhere we are seeing, right? How can software enter into the vehicle industry? How can software enter,
So infotainment systems, self-driving features, which are there right now, correct?
The way how software can enter into vehicle industry is through EVs.
Okay.
Because electric vehicles can be easily controlled by the software, and they can easily since they have lesser mechanical parts, they have the intelligent systems, they have motor controller. So since this whole domain is related to electric, the software and everything, so it can give a boost to the software industry. That's why governments are now pushing towards the electric vehicle technology. So that is the major reason for this shift.
So you are saying with more EVs, we will have more software jobs as well.
More software jobs, more autonomous vehicle, more room for software companies to penetrate in the sector.
Right.
Just I will give you an example. In Tesla, mostly there are software engineers rather than mechanical engineers. There are more software engineers than mechanical engineers or electrical engineers. Google is developing its own, its platform for software, right? Apple is developing its own car, Apple car, right? Sony developed its own electric car.
Right.
Because they are trying to penetrate this field, trying to take, even eat a chunk of it, right? So that's why now governments are pushing for this particular adoption.
So because governments are now pushing the EV industry, there are more breakthroughs which are happening.
Yes.
So everything that we see from maybe the range getting better, or maybe on the micro level, the cells getting better, that is because now government is giving an incentive also.
Yes, government is giving incentive. So this is the major push, what we say in terms of economics, right? And plus, yes, there are some environmental concerns also, right? That also can be tackled much more effectively. One, like I'll just put a question to you and audience one. People think EVs are environmental friendly, right? But where the electricity is coming from? It's coming from burning the coal, right? So how do we say EVs are eco-friendly?
Right.
So the thing is, EV becomes very eco-friendly when we have a renewable source of energy, right? And how EVs may help us to tackle the pollution problem even by using the coal as a fuel for electricity or oil as a fuel for electricity. Because when you drive EVs, the local pollution reduces.
Right.
The pollution is only at the power plant level and you can control it easily. Here, when you have a lot of vehicles going on the road, you can't, many people even drive without the pollution certificate, even now in our country, right? But when we have electricity generated at a power plant level, I can effectively control the rate of pollution. I can bring more measures to control there, and the pollution which will be there, that will not come to the city.
Since you're talking about pollution, so in IC engines or the cars, right, they could be used for 15 years and then they had to be scrapped. I mean, that is according to the current laws. So how much can I expect if I buy an EV today? What is the life of that particular EV?
Yeah, so it actually depends on the cell chemistry which we are using.
Right.
So a lot of companies are giving, some are giving 5 years warranty, 3 years warranty, 10 years warranty. FAME subsidy says 3 years is mandatory, right? Some maximum you will get 10 years, right? Okay. After that you have to change the battery.
And what happens with that battery? Is it can it be recycled, or like how?
Yes. So the battery which we use first for EV, it can be used for second use. Second use we can do in 3 ways.
Okay.
See, an electric car, the battery we use, you need for acceleration, you need power in that battery, right? You don't want your electric car to move sluggishly, right? So that battery you need new. But when we talk the batteries for energy storage system or solar or wind, you don't need acceleration, you just need to store energy. So once a EV's battery is used, you can reuse that battery in solar or wind energy, or what we say energy storage system, because there you don't need peak power demands, or you don't need acceleration, you don't need high current, you can use that battery. So one use is this of that. So to answer your question, after some years of use of your battery, you can probably resell to a authorized reseller, a recycler of the lithium-ion battery, which will further use it to solar or wind, right? Other than that, companies will also reuse those materials, right? The raw materials in a lithium-ion battery can be recycled, can be extracted, and that is what is called as a urban mining.
Okay.
Right, this is a new concept I want to just share with the lot of all the listeners. So one more thing I'll just share and I'll put as a question to all of you guys, right? In India, we don't have lithium ion reserves, right? Most of the lithium ion reserves are in, I think, in other countries whose mines are controlled by China, right? We import our cells from China, we make battery packs and we put it in the vehicle. Right?
Okay.
So how are we going to tackle this problem of localization when we don't have reserves?
Right.
So there's a concept called urban mining. Mining is one where you take out the resource from a coal reserve or a reserve of a lithium, let's say, right? You make the battery out of it. Urban mining is you take those materials from the existing batteries.
Okay.
That's why name urban and mining, right? So that is going to be very good or big opportunity for our country, where what will happen is once I drive a EV, I give my battery to my let's say authorized distributor or seller or my manufacturer. He will take the materials out of this. He will not mine from a reserve, from a mine or from a reserve, right? He will mine from my existing battery and make a new battery out of it. And that is what is called as urban mining, which is going to be a very big opportunity for our country. It is estimated almost $200 billion of this industry which is going to happen in our country, and which is a very good potential. And here's what a lot of listeners can even develop the skills and think as an entrepreneurial opportunity.
So you're saying EV not only helps to reduce pollution while you drive it, even after an EV's life has ended, when the battery's life has ended, it gives more push to, solar energies and green energies in general. Right?
Yes.
And at the same time, you're saying there's a huge market, not only for EV right now because it is currently trending, but for localization, wherein the cells that we currently have in EVs that are being developed or being imported from China or maybe from other countries. So we are not developing it in-house right now, but if we go by urban mining, we will be able to be self-reliant.
Yes.
So, okay, let me now steer this conversation towards jobs, right? So now that I know that EV has a lot of scope, right? Because what I see is, according to the news sources that I've read, fuel sources that we have right now, be it petrol or diesel, in the next 50-60 years, it will be very difficult to source them, right? And mostly people will go to EVs, which basically means if whatever mechanical industry we have right now, they have to go through a revolution.
Yes.
So what is your view on that? Like, what should the people who are there in that particular domain, who are working on these engines, even the blue collar jobs which are there, which are related to this field, how can they prepare for this change?
So yeah, like you said, yes, change is going to happen,
right?
In this industry. We are probably going to see a shift after so many years into this industry. And yes, why, like I told you that since we need software to come into the vehicles, this EVs shift is going to happen.
Right.
And again, the reason, because tomorrow we have to go with autonomous shared and electric mobility.
Correct.
Right. We want more autonomous vehicles to come. We want more shared mobility to come, right? Where we can utilize our time in the vehicle for other activities. It will automatically navigate and will be more safer vehicles. And this is the reason some of the OEMs are working as a cab aggregators and electric vehicle manufacturing companies also.
Right. Blue cabs we have heard about.
Ola you have heard about, Ola Electric, and you have Ola cabs. So they are trying to, make electric and make it a use case by making a shared and autonomous mobility. Coming on to the jobs, yes, already there was a mechanical industry and now you have put a software on this. And with software, the link of software and mechanical is electrical industry, right? So we need to upskill our skill sets to match this the competence which is required for this age of electric, right? As we say, this is an age of electric, right? It's the age of software. So the existing mechanical engineers or existing people, I think they should definitely, even though they will be continue working into the same domain, but they should be well versed with the electrical concepts, with the software concepts. The reason is because tomorrow, if even though I'm designing a mechanical arm of a robot, right? I should know how to fit my PCB, or I should know how to fit my, how my wiring should go. Because earlier there was let's say in a mechanical car, earlier there was a mechanical brakes, which is a this oil pipes and all. But now in electric cars, you may have regenerative brakings, where you will have the electric cables going, right? So the mechanical engineer should be exposed to the constraints of the electrical and software world so that he can accordingly design his system. So yeah, they have to upskill to these skills.
So as I see, like in any sector, there are people who actually work on the product, then there are people who manage the labor, right? And then there are people who are probably GMs or VCs who are sitting and managing the company. So on all these levels, what kind of like people who are actually working on the product, they have to upskill. That we understood, that they have to work on the product, they have to understand whatever new technologies are coming and how they can basically contribute. But what will the managers and the GMs, these people do who are, managing these people right now? They are able to manage because they have the expertise for the mechanical domain, right? But now that we are shifting to EVs, will the companies hire new people? I don't think that they will do that. They will have to upskill their employees, right? Because you cannot fire everyone and then get new people in. So how can these people prepare for that shift, right?
So, like you said, that already people who are in industry, they are not well versed with the concept. I'll just give you an example. If you open the textbooks of engineering, I'll talk my engineering tenure, right? A decade back, I don't see much about EVs on those curriculum, right?
Right.
Yes, because what happened is we got exposed to this technology after Tesla's Roadster to lithium-ion technology in 2008, and our curriculum is of 1950, 1960, right? And this is a evolving technology. And the let's say people who graduated from these colleges as a mechanical engineer, they have come to this the corporate, they have worked as a mechanical engineer or line engineer or in the same for a long time, and suddenly they see EVs are coming into the picture. So they will have to invest some time and in understanding these concepts, obviously.
So what concepts are we talking about? So let's say I'm from mechanical background.
Yes.
So having mechanical knowledge, just the mechanical domains knowledge, can I survive in this industry, or I will have to learn about electrical concepts as well?
If you don't learn about these concepts, while you work, you will learn.
Okay.
Yeah. That is something either you can proactively learn or reactively learn. Right. For me, what happened is I graduated as an electrical and electronics engineer. I was not much aware initially about mechanical concepts, but when I worked, I had to learn.
Right. Okay.
But when you learn proactively, right? When you learn,
you get ahead of the curve.
Yeah, you get ahead of the curve.
Got it. Okay, great. So you're saying people who are on the managerial positions right now is the time that they should think about upskilling.
Yeah.
If they don't upskill, the companies will make them upskill.
Yeah.
Right? Or the situation will become such that they will have to upskill to grow.
Just think on this one thing. Hero MotoCorp, right? Invested in Ather Energy.
Okay.
Right. It has a major stake in Ather, right? Why would a company who has tons of years of experience, who have very senior people, invest in a bunch of IITians who are just recently graduated?
Right. No, correct. You're right.
Because the new generation is more well versed with the technology, more well versed with the software part. They are more into, this the transition is happening, right? So if the legacy people don't, get themselves, or not, it's not about legacy. If every one of us doesn't keep the pace with the change in time, we will have to either do proactively or reactively. We will do reactively. That's it.
Got it. So now we've spoken about people who would have to shift to EV. Now let's talk about people who are already ahead of the curve and they are there in the EV industry.
Yes.
So what kind of jobs are there in the EV industry right now that I can apply to?
Right. So like I was talking about, that there's already a mechanical on which there's electrical things, right? So first thing is I'll talk about mechanical parts, right? When we design, let's say, a subsystem, right? Let's say a motor. So a mechanical design engineer is one of the position which is being looked out, right?
So a design engineer is a person who does what?
So mechanical design engineer, for example, I'll talk about this mug, right?
Sure.
So a design engineer will know, okay, what is the usual height of the fingers of a person? Accordingly, it will design this curve, right?
Right.
It will not do minimum or more, right? it will see the agronomics of this particular thing. It will see the weight should not cross, which is not uncomfortable for a person to hold the mug. And it will design the aesthetic elements as well, right? So in the EV industry, one of the position which is of mechanical design engineer, where he designs the packaging of the subsystem. Let's say my battery, right? Let's say I have to put cells in this. So I'll design my battery in a way that it is thermally efficient, it is lightweight, it is safe, it has strength, right? So one of the core job which is looked out is packaging engineer or mechanical design engineer.
Okay,
right?
All right. So for this, what skill sets are required?
So mostly for this you need a good knowledge on CAD, right? Let's say you can know SolidWorks, you can know CATIA, you can know Siemens NX, right? And you should be well versed with the design aspects, right? One thing is you are sketching, right? It's not about sketching engineer, it's a packaging engineer. You're using those tools to create a design, but you should know the constraints of design also. Geometrical tolerances, the manufacturing constraints. Let's say you have to give it for injection molding, it will shrink. So you have to keep that shrinking tolerance as well, right? So these are the skill sets which are required.
So I'm assuming these people are also required in the IC engine world where combustion engines are there and we are developing those cars.
Yes.
They're required there as well, right?
Yeah.
So for those people, it is a straight transition that they can do, or before moving into EV, they have to learn something.
Yes. It's not a straight transition. Again, I said, for example, I talk about charging stations, right? In a charging station, when a mechanical design engineer has to design, he should know, let's say that, for example, my PCBs are getting hot. So he has to design the airflow according to the PCBs.
Right.
But for that, he should know the basics of PCB.
Got it.
Right. Not in depth that to design a PCB, but he should know, okay, PCB needs to be cooled. Or the electrical component needs to be cooled.
Or which part or which area in PCB has to be cooled.
Yes. He will design the design, he will make the vents accordingly, he will make the fan accordingly, right?
Right.
And he should know, okay, PCB should not get in contact of water, or there should be ingress protection, right? So he will design the packaging that way. Or other very good case, I'll take for example the chargers, right? Lot of the chargers which we get from we buy with the electric two-wheelers, they usually have a fan on that. So that fan placement is done by the mechanical engineer, right? But he should be knowing where is the MOSFET placed, right? Which part gets heated up. If this part gets heated up, you don't want to put fan below that, right? You will want to put fan which parts get heated up. So you should be well versed with the basics of those components.
So okay, got it. So this is about the design engineer. What other profiles are there?
So I'll just first finish the mechanical one. One is in mechanical design engineer. Other profile is the CFD engineer, right? So very important part which you see, like you always, you might have heard news of EVs getting catching fire, right?
Correct.
And some battery blasting and all those things, right? So obviously thermals need to be managed in a EV so that it doesn't get heated up.
Right.
So there's a need of the engineers who are very good in thermals, who know the CFD, which is called computational fluid dynamics analysis, CA analysis, where they can simulate, okay, in this temperature, how much my battery is going to heat it up, how much current discharge should I allow. Now again, there's a change in the shift from IC to EV now, right? In IC, he used to work on coolant system, radiator. Now in EV, he's working with the electrical engineer, okay, this much current discharge, this much heated will take place. So you should not allow this current discharge for this time. So as I was talking about that, there's a very good chunk of opportunity for the simulation engineers, which will do CA, CFD simulation to know the feasibility of the thermals of a EV, right? How much hot, cold its subsystems are coming. And definitely a basic know-how of the electronics and electrical components are required to navigate this change, right? Okay. And I give you an example of a charging station. He has to work on the airflow and all those things, right?
So what is this profile called again?
So you can call it as a thermal engineer, CA, CFD engineer, simulation engineer, right? So it depends on the organization in which way he wants to orient that particular skill, right? But in a nutshell, you can probably call it as a CA, CFD analyst, right?
So somebody who is already there in the domain, like somebody who is working on IC cars right now. He's called the same, like the profile is same in that particular.
The profile is same, but you get a preference if you have exposure to the electric vehicle concepts.
Right. Nice. So if that guy has to transition here, he has to know about the electrical components.
He should know. Otherwise, he may design something unintentionally wrong, which may not suit to the systems or requirements of electric.
And if somebody wants to get into this profile, then what does he have to do?
The best way I see is to upskill themselves, right?
Upskill how? Like, what should I learn exactly so that I can get into it?
Yeah. So if somebody wants to get into it for a CFD engineer, one thing he should definitely learn about is the battery thermal management system.
Okay.
How cells are heated. For example, cells boundaries are have lesser heating than the inside. So he should learn about the cell structure, cell chemistry, the cell heating characteristics, what equations to use, right? And cell heating based on the current discharge profiles. These things he should learn, right? So one is this, other is the cooling systems he should learn, the airflow cooling, right? Lot of EVs you see the motors are placed with an exposure to air, right? So that they could get cooler when the vehicle is driving, right? So he should know how the airflow he has to navigate and what are the characteristics of heating up of the motor or other subsystem. So he should well versed on the heating characteristics of the subsystems of EV. So that thing he should definitely upskill himself.
Got it. So we spoke about design engineers. We spoke about this profile. What are the other profiles that someone can apply to in the EV space?
Yeah. Now I'll just jump to the electric profiles in the electrical, electronics and software. But before that, I'll just touch upon I'll just say one line on this. There's one more profile called MPD Engineer, right? New product development, where the MPD engineers will make those products manufacturing ready, right?
Okay.
How is it manufacturing like feasible in terms of manufacturing? Like we take the example of this mug. So he will see, okay, what is the mold feasible? Is its manufacturing feasible, right? So this is one more profile which is looked on. More or less, it is similar with as compared to IC and EV. Just still, knowledge of EV is better. For example, in battery nowadays we are using aluminum casing. So he should know, okay, how aluminum cools, what is the manufacturing process of aluminum, how the mold works, right? Is the design as per the mold? The draft angles are given. What are the extrusion process, the die cast process? All this he should know. So this is one more profile. Now coming to next set of profiles, which is electrical and electronics profiles, right? In electrical and electronics profile, there has been a surge in demand in EV. They were not in much demand in IC, where you see electrical involving only in starter motor or the battery or lightning, infotainment. Now it has directly come to the propulsion system, the thing which is driving the EV.
So what is it called? The propulsion system?
Propulsion system is nothing like for an gasoline vehicle, engine is a propulsion.
Correct.
It propels, right?
Correct.
For an electric vehicle, motor is a propulsion system. Battery is a propulsion system.
So what do you call that? Is there a name for that motor?
So motors, we have different motors, right?
So for propelling the car forward, like what do you, like for example, what I'm trying to ask is, if I have an IC car, like the heart of the engine is the heart of the car is called the engine.
Yes.
So in EV, what is that? Which not the cell or the battery, but what is it that which drives the EV?
We say powertrain system as well, right? And the one which drives is the battery coupled with motor.
Okay. So that motor is called powertrain?
Powertrain is mix of battery, motor and the gear system, right? So just to give an example, like for if we talk about our body itself, right? So you can assume this is our motor, right? Our joints, but it needs the battery, which is our blood, right? It needs that pump, right? So either this or this, if doesn't work in sync, our system is not going to work in sync, right? So similarly in EVs, we call whole set as the propulsion or powertrain system, which involves battery, motor and all the gear system. So you got a very interesting thing that if in a EV, my battery, motor and other subsystems are not in sync, my EV will not perform, right? So our engineers, the new demand is one more, which is engineer should not only have good technical skill but communication skill. In terms, he should understand. I don't mean by communication skill having good English. It's just able to communicate and understand the requirement of other subsystem also. Let's say you are a battery and I'm a motor. I should work in sync, and my creators should also work in sync.
So if I belong to the battery team and you belong to the motor, we should be able to communicate with each other.
A lot of cross functionality is required here, which was not too much prevalent in IC. They are also prevalent, but in EV it has suddenly gone because a lot of communication happened, right?
Plus it's a new industry also. A lot of rules and processes are being laid down.
We'll talk on regulations as well, right? Once I complete on the profiles. So next, we were talking on the electronics front. So in this propulsion system, so one has to design, let's say, the battery or battery management system. Now lithium-ion batteries have included a battery management system, which were not present in lead-acid batteries. A question for the audience or you as well, like why there was no battery management system in lead-acid and suddenly they have, involved in lithium-ion?
I have no clue.
So, it's just an observation, right? Earlier batteries you used to see, like they used to put water into the batteries and they used to charge, right?
Correct.
Now there was no electronics involved. Suddenly we are trying to include a lot of electronics in battery.
So when you say electronics, so I understood the example where you said ki a battery, we used to add water into it. Now we have dry batteries.
Yes.
So the technology has changed?
Yes, the technology has changed. Now we have moved to lithium-ion batteries. Like I talked in starting of podcast, we transited from EV to IC because we had battery issue, we had range issue. Now with the advent of lithium-ion technology, which happened in 1900 something, like Professor Goodenough accelerated this transition. After this transition, these lithium-ion batteries were able to give more energy at less space. Means more range. My user was getting more range, right? But problem with the range is more range means more energy.
So charging time will be more.
Not only charging time. I'll talk about the gas cylinder at your home. It has more energy.
Right.
Is it safe or dangerous?
For driving it is dangerous. But at home it is safe.
Yeah, at home it is safe, but still it is flammable, right?
Right.
So once you pack a lot of energy at a space, it becomes bit, dangerous or, and that's why you needed electronics to monitor those cells.
So you needed a control system for that.
Yes.
And hence the battery
management system came into the picture.
Right.
So talking 18th century, there was lead acid battery, working on water, not much energy, packed in a space, right? Not much range. So you don't need to control them, right? Now suddenly lithium-ion batteries have come that are like gas cylinders, right?
Right.
They're explosive, right? Lithium is a very reactive element, right? So here you need somebody to monitor, keep an eye on the battery. And also other reason was you don't need balancing in lead acid batteries. Why you need balancing in lithium-ion batteries? So example, there's a chariot, right? And there are 5 horses driving a chariot, right? The speed of the chariot will be equal to the fastest horse or slowest horse.
The slowest horse.
Yes. So if in a chariot, if out of 5 horses, if one drives very fast, it's going to hurt the slowest one.
Correct.
Similarly, in a lithium-ion battery, I don't have a single battery. I have a lot of cells. If you see, it's a stack of cells, right? If one cell tries to run very fast, it's going to hurt other cells.
Right.
It's going to discharge the other cells. So I need somebody to keep an eye on the temperature, the safety, the balancing, and also to penetrate software into battery. I need someone to communicate to outer world how much range is pending, how much more my car will drive. So that's how I can penetrate software into the battery as well, into my EV also. So that's why suddenly we need a battery management system in lithium-ion batteries, which was not there in lead acid.
So who manages this BMS? Is there a separate person who does that, or a separate team, or a separate profile who just specializes?
Yes. There's a separate team. Usually, like in our company also, there's a BMS team, there's a charger team, there's a motor controller team, right? So that BMS team creates the BMS, which makes sure battery is safe, reliable, performs. and also creates in a way it is compatible with other system. It is compatible with the charger. It is compatible with the motor controller as well.
Right.
And there are certain set of profiles in the BMS as well. So 3 profiles I have already discussed. One is a packaging engineer. You need a BMS packaging engineer as well. You need to package that BMS in a battery so that no water, dust or things like thermals are proper. You need to properly dissipate the heat of the MOSFETs, right? Then next what I talked about is the CAE CFD engineer. So he will do the simulation on the heating of the MOSFET of BMS, right? My BMS is not getting heated up. Imagine if your electronics is getting fire inside a battery, what will happen? Your battery is going to get fire, right?
Correct.
So these BMS have to be very, very, thermally stable so that they don't catch fire, they don't get overheated up. And a NPD engineer who will take it to manufacturing level. Now comes who will develop this BMS. These were the thermal mechanical parts, the electronics part. So one of the engineer will be my embedded hardware engineer. Hardware engineer will design the schematics and layout of that PCB, right?
Okay.
It will design that PCB of that battery management system. One profile will be this embedded hardware engineer.
And I'm assuming this profile you will already get in the market because there are people who can design PCBs already.
True.
They need to have a knowledge about EV and then they can come into this.
They need to know the application level knowledge of so that they can design PCB.
But I'm assuming there will be some roles wherein if I come to the company, they will train me on EV and then I can just go about my job, right?
Yeah, see, to be very honest, let's say I'm looking for a BMS lead in my company, let's say, and I'm looking for a hardware engineer. I would want somebody who has exposure of that BMS.
Correct.
Because what will happen is, otherwise he will design a PCB which is not thermally compliant to the battery, right? Let's say my PCB overheats, right? He doesn't know that, okay, this much temperature I have to keep, right? That may end up heating my cells, right? Or like my BMS monitors, right? Ultimately that BMS has to monitor cells. So that engineer should know the cell chemistry, should know about the cells, right? So somebody who is very good at hardware but exposed to these domains is one who is preferred in this.
So I have a very quick question here. So if let's say the EV industry is new, so how will you hire experienced people in this industry? You will have to upskill them or the company will have to take the pains of upskilling them, right? So how does that work out?
So 2 ways which worked, right? Like I said, proactive, reactive, and both have to be done, right?
Okay.
Some theory, some experience. One thing is, what we also do, we give some material to new joiners. Okay, you learn this, right? You go through some courses, you go through some YouTube lectures, right? What are the different subsystems, how these things happen. Second thing is, you work on that. So when you work on that, when you know the theory, you automatically get trained to that thing. And when you face failures on the field, so you automatically get the gist of that particular thing.
So my question was more about hiring. So do you look for experienced people or are you okay with people who have exposure to the driving industry and then you take the onus of making them EV ready? Like how does it work out?
Yes. So to answer your question, if I'm hiring a fresher, I'm hiring a GT, I will not look for exposure of EV from him because I know he's not exposed. Right. What I'll look for is the basics of the electrical concepts, basics of motors, basics of battery he knows. If he's exposed to EVs, I'll give a preference. That shows he has a passion.
So when you say exposed to EVs, if he had a EV course in his curriculum?
EV course? He knows about EVs to some source.
Okay, yeah.
Right.
All right.
Any EV course, he has done a project on EV, he has done, like for example, in my college time, I created a solar electric car, which it was a 4-seater car, we won, it came in newspapers as well. So
that helped you?
That helped me, right, to enter that industry. That shows your passion, that shows your commitment to that particular field.
Right.
And that shows that you can practically handle the challenges which you may face in field.
All right.
So yes, you get an edge when you are exposed to that particular thing.
Sorry, I'm interrupting you, but the freshers, you mentioned that you hire freshers.
Right.
So when you hire freshers, what profiles do they go in?
Yes.
Because they don't know anything about how things work.
So, yes, when we hire the freshers, if I'm talking about electronics, either they will be hired as a hardware engineer or a firmware engineer.
So irrespective whichever profile they're going into, you will train them.
No, basic will create. Basic that is he's coming to hardware. For example, you are an electronics engineer. I'll probably hire you as a hardware engineer.
Okay.
Right. Let's say you are a computer science engineer or a electronics and communication with embedded background. So maybe I'll hire you as a firmware engineer. Right. It will depend on your interest also. But I'll just tag you a broader. That is the first year, let's say, of a college. You are just doing the. Then when you come and work on the subsystem, you will pick a subsystem. Let's say you have interest on charger. You will start working on it. And then when you switch the industry, you will get as a job of a charger hardware engineer or BMS hardware engineer.
Because usually in the software space, the way it works is because obviously the college curriculum is way out.
Yeah.
It is very old.
Yes,
right?
yes.
So if I'm getting hired in an Infosys or a TCS, right?
Right.
They train me on the project.
Yeah.
I will have knowledge of basic programming that I've learned in college. They will train me on the project and then I'll start working on that project. So assuming that I come from college as an electronics guy, I will not know how to design a PCB. Maybe theoretically I know it.
Yes, yes.
But practically I've never done it in my life.
Yeah.
Right? So when I come into your company, you're saying while you're working, you will learn it.
Yes, yes.
So you don't proactively teach. I'm talking about the entire EV space right now. They don't proactively teach or upskill their employees. While they're working, they learn from the seniors. Or
to the extent how it is happening into the software industry, they don't do proactively. Reason because most of them are startups right now in EV. And in startups, it's just run.
You wear multiple hats. You do all the work and then
it's an agile method. You work as you learn. Hardly 1 month of training, job shadowing, and then they put you into the work. But if you are a fresher, my suggestion will be to get through your basics thoroughly. Once basics are clear, if you have inclination, you have passion of this field, just start learning about that thing and try to implement something through a project. That will take you there.
So people who are freshers are from electrical and mechanical background. For them, if they are passionate or if they studied well, they can get into the EV space pretty easily if they, keep their job hunt active.
Yes, yes.
Okay.
And that gives you an extra edge. Like I said, some project on EV or some, any upskill course they have done, that gives you an extra edge.
Got it. So we spoke about 3 profiles and then we spoke about the fresher profile as well.
Yes.
Apart from this, any other space that we are missing on right now?
Yes, yes. So like I was talking on the embedded part, electronics part, one we talked about the embedded hardware engineer who will design the PCB of that thing, right, of my BMS or my motor controller. Next that is my hardware part. My brain wiring is done. Now I should have the firmware also inside of my PCB, how it will behave, what will be the response. To give you an example, let's say my battery has heated to a certain temperature. You wouldn't want your battery to cut off.
Right.
Otherwise, in the middle of a road, your car, it can meet an accident, right?
Correct.
You would want to give a warning to a user, right, that slow down or, park your car inside. And so those logics, that brain, the firmware, has to be developed by the firmware engineers.
And what technology is used, like which programming language is used here?
So usually what we are using right now is embedded C.
Embedded C. Okay.
Embedded C is probably used. But others are being also explored, right? And I'll say with the evolution of ChatGPT, it has become very easy for the embedded engineers to program a lot of things.
Right. To learn to program a lot of things. Yeah. I'm sure ChatGPT does not give you code which is ready and you can just plug and play. Right? You have to know that code in order to make it ready.
It makes your work fast.
Yes.
It does the base work for
all the boilerplates and other things in software that you had to write, you don't have to write that anymore.
Yeah.
So GPT helps there.
Yes.
Great. So a guy who is getting into firmware engineering is a guy who's probably like a software engineer to you.
Either he can be electronics engineer or an electrical engineer, or he can be a computer science engineer, right? Okay. So there's a difference between a software engineer and a firmware engineer. Firmware engineer gives the software for the hardware. Right. So he should know the basics of the electronics, the basics part, right? And the basics of the end functionality. And he should have a very keen interest or desire in programming, because if you don't have a passion for programming, you will be stuck up in bugs and you won't solve it, right?
Understood.
So a person with a passion and good exposure to programming language, not a very hi-fi, just good exposure to embedded C or C++ is fine. any one microcontroller he can start working on, right? And then he can easily enter as a fresher into this industry.
So when we talk about lateral hirings, maybe somebody who is working in a printer business where he's writing firmwares for printers,
Yes.
right? Or somewhere he's writing some program for some device, could be a microwave, could be a refrigerator.
Yes.
Those guys become your target audience for this particular role.
Yeah, for freshers, we are not expecting any experience from them.
Right.
But for higher roles, we expect some sort of experience in EV industry.
You do? Okay.
Yes, we expect. It's not mandatory to, like, it's fine if somebody some from some other domain comes, right? It's fine, they can come and learn easily, but they will take some time to lead that chunk and to understand that subsystems.
So freshers, what do you check in freshers exactly for a firmware engineer?
Yeah, so for a fresher of, let's say I have to hire a fresher in firmware engineer, as a firmware engineer, he should be versed about the embedded C and embedded C++ concept.
So which is taught in college. If he's a computer science grad, yes. In electronics, I think it is only taught in first 2 semesters.
It is taught, even nowadays it is taught in schools also. A lot of people are, it's just like, even if you are exposed to Arduino, you are exposed to some sort of C programming, right?
Right.
So exposure of this C language plus a knack for solving problems is what we look. We don't ask him to write a program, we give him a problem solving statements, right?
Do you also check for data structures, algorithms?
Yes. Okay. So we look for algorithms engineers as well, data structure as well, because why algorithms also are playing an important role in this industry right now. So for example, if I talk about your cell phone, right? It shows a state of charge, let's say 80% charged or 40% charged. Have you observed in your phones that after a year, 10% charge doesn't go for the same amount of time?
Right, yes.
It reduces, right?
Yeah, the battery ages.
Right?
Correct.
So earlier 10% was half an hour, now it may be, let's say 20 minutes or 15 minutes. But let's say I'm in an electric car. It's showing me 20 kilometers for day one for 20% charge. After 1 year, it's showing again 20 kilometers, and you may drive according to that only. Okay, my home is 10 kilometers, but it's like 20 kilometers showing. If it shows you incorrect information, what will happen?
Right, I might be stranded.
You might be stranded, right?
Yeah.
You can afford that inaccuracy in your state of charge algorithm in your phone, in your laptop, but you can't afford in EV. So that's where there has been a lot of demand of very good algorithm engineers who can design algorithms which can adapt to the battery aging to tell the user, okay, how much battery is left, how much kilometers it can charge, right? So that's also algorithm engineer is what being looked out. State of charge, who can design algorithms, state of health, state of power, how much energy he can take, right? He can go into ride mode, eco mode, or whatever, right? So this is one more profile which is being looked out. Yeah.
Okay. And so this was about software. Then any other profile that we probably would have missed?
Yeah. So one is more application engineer, right? So just like algorithm engineer, we have a lot of application engineers. So even though as a hardware engineer, as a firmware engineer, I would like to communicate and have my application level sorted out. But there will be a separate engineer who will create an architect of a product. Like on the application level, how should it perform, right? For example, I'll give you an example. In an EV, I would want maybe my EV to have a 100 km/h speed in this seconds. So my application engineer will define, okay, this should be my current rating. This should be my battery capacity. This should be my range, right? So these kind of engineers are also being looked out, right? They are also called as customer success engineers, right? What they do is they ensure that at customer level, as a user, your product is successful, right? So those profiles are also looked out. And this customer success engineer or application engineer gives the requirement to hardware and firmware to design hardware and firmware accordingly. Yes.
So I also heard about a profile called simulation engineers, people who actually simulate battery packs in probably a software, and then you give it to the software guy so that they can test whether their algorithm is working. Can you shed some light on that?
Yes. So in a EV company, there is usually a team, vehicle dynamics and performance teams, right? In which there is an algorithm engineer, in which there's a simulation engineer. The work of these engineers are to ensure the range, the speed. On the application level, same, there are application engineers, right? So these, what they do is, for example, how should I know a 2 kilowatt hour battery for my motor will give a 50 kilometers of range? It will have multiple factors. It will have weight, it will have, the aerodynamics, the shape of the car. So in that case, I will need somebody to simulate.
Right.
And why do I need to simulate also, right? Because tomorrow, I don't want my vehicle to get created, go for a certification, spend money and get it failed. Simulation saves me a lot of time and effort into creating a right fit of product.
Actual model without actually investing a lot of money.
Yes.
Okay.
Earlier there were not simulations, right? So the companies like big companies, Mercedes, BMW, they will have to, multiple vehicles they used to crash, right, in that crash test, and that used to fail. Right. So that's why it has become very important, and these simulation engineers usually work on MATLAB to find out whether in terms of crash, in terms of your range, your charging time, everything is as per the desired for the user.
So when we talk about MATLAB, right? So MATLAB is a premium tool. Now, if I have to practice, how can I practice if I don't know MATLAB? And second question is MATLAB as a tool prevalent in the industry? Like wherever I apply, if I have to know simulation, will I have to have experience on MATLAB? How does it work?
Yes, so MATLAB is one of the most preferred tool for simulation in the industry. Yes, it gives you an edge for doing the simulation and a preference because it's a standardized tool now, right? How to learn that? Simple answer is practice. You should know the basics, right? Basics of the embedded C coding, the simulating in that, and then you should practice different concept, different simulations in that.
Like for example, in MATLAB, when you do coding, there are online compilers where you can do it, right?
Yes.
So that becomes free. But what about the actual simulation? Is there an alternate software where people can practice?
There's one more software,
which
Octave.
Is probably open source or free?
Yes, Octave is a open source software.
Okay.
They can practice. I'm not sure on its simulating capability, but coding you can do on that, right? Yes, you are right that it's expensive, but somebody can try this student version license or things like that there are. So yeah, getting a grip on MATLAB really helps because it gives you near to actual results that you would want in industry.
And I think this will be prevalent across all the profiles, even though you have the knowledge. If you don't have knowledge on MATLAB, that can be a setback, right?
It's a setback if you are a simulation engineer. If you are a algorithm engineer, then it's a setback. Okay. If you are a hardware engineer, firmware engineer, it's good to know, but not necessary.
Not required.
Yeah. Okay. One more profile, just talking about this simulation also. Like we talked about embedded hardware and firmware engineer. There's also requirement of power electronics engineers in the market, right? Because embedded hardware will design the PCB, right? Will design the schematics of the PCB. The PCB engineer, there's another profile which will design the PCB that it is as per the EMI, EMC or the radiations are not more or less. Will do the tracking and routing as per the size. And this third engineer which is required, which is a power electronics engineer. What it will ensure, the MOSFETs I'm selecting, the power board, right? Because there's power flow happening, are as per the, the thermal requirement or are compliant to my requirement, right? So in electronics, if I want to create a good BMS, I need embedded hardware, I need embedded firmware, I need a power electronics engineer, and I also need a PCB engineer.
Okay. So now that we've spoken about the job profiles, I want to understand like how much can people expect when they're getting into the EV space, right? So let's start from freshers. So freshers, if they're applying to EV jobs, in all the jobs that we have so far discussed, like what is the package that it varies from? And even the lateral hires, if they're moving from a different industry to EV, how much can they expect from their traditional role where they're probably earning whatever they're earning in IC? How much they can expect over here?
Yes. Yeah. So in terms of salary and CTCs, a fresher who's entering into EV can expect somewhere around 6 to 12 lakhs per annum as a CTC, right? Based on the role he comes, right? Usually I've seen that embedded firmware engineers or embedded hardware, electrical electronics CS side gets more chunk as compared to the mechanical engineers.
Okay.
Right. in beginning as well as they move forward. Coming to the roles which are for the experienced roles. So if you're working in a traditional company, EVs usually, there are a lot of startups in EV, right? So a startup usually gives you a good, like say 30% more salary as compared to your existing, what do you say, pay scale in a conventional MNC company.
Okay.
And there's a rule which I'll share, which a lot of companies follows for this CTC, deciding the CTC. It's usually for a non-startup company 2 to 3 lakhs per annum and 3 to 4 lakhs per annum for per annum of experience for experienced company. What I mean to say, let's say you are a 6 years of experience, right? So if you're a 6 years of experience and you're going to a established company or a MNC company, so 6 into 2 or 6 into 3, what is that bracket? 6 into 12 or 6 into 3, 18. So your CTC will lie somewhere between 12 to 18 lakhs per annum.
With 6 years of experience?
Yes.
In the relevant domain. Like with EV, if I am from the EV space, if I have 6 years of experience, I will have this much back.
Similar domain, not necessarily EV, but your experience will be considered, right? Same, just same domain will help you more, right? And let's say with 6 years of experience, you're entering into the startup, it's usually 3 to 4 lakhs per annum. That is 6 into 3, 18, 6 into 4, 24. So your CTC should be somewhere around 18 to 24 lakhs per annum.
Got it. Okay.
This rule is going to, disappoint a lot of HR people. But that's a usual.
But at least we now understand like how much can we expect. So is it on the same track as what is expected in the like traditional car companies? Like if I get into Hero MotoCorp and assuming they don't have any EVs right now, will I get the same pay scale there or is it better in EVs?
Yeah, so Hero MotoCorp, let's say it's working on EV as well. So it will give you from in that multiplier only 2 to 3 lakhs per years of experience, right?
Okay.
But if you're getting into a startup, you will get a more, let's say 30-40% more salary should be there for you. So conventional companies are not much differentiating as much as compared to startups for this new skill set. But see, in startups you have more risk, right? So it's like more risk, more reward.
So what do you mean by risk in startups? you mean job security?
Yeah, you have that.
So because you never know when the funding might go dry. And the
your expectations will be more. So both the industries have their pros and cons, right? But there you will have a lot of learning as well in startup, a lot of agility, right? Dynamism will be there. You will work a lot of people who are young and enthusiastic, right? But there will be some sort of insecurity as well, right?
And if you talk about major players in the EV sector and just in India, like which companies are available to me where they're actively hiring in the EV space?
So if you talk about the startups, first of all, I'll talk about my own company, Simple Energy, right? We always look for great engineers who can have passion for EVs and who can help us, make the best EVs in the market. So you can definitely go to Simple Energy careers page to, look for that. The competitors of Simple, we have Ola, we have Ather, and we have, some established players in EV. We have TVS who is working on iQube, the electric two-wheelers. It's working. You have like Hero MotoCorp, you have Hero Electric, you have some companies who are working in four-wheeler, let's say MG. MG is coming with its own EVs. So a lot of people, a lot of freshers are being hired in MG as well. So they can look after these companies established as well as the startups for entering into this segment. My personal suggestion will be to start your journey with a startup. Because that's where you will learn, you will get an exposure, which is very much required when you want to lead people.
So will you still call Ola and Ather as startups, or like how does it work?
I don't know what is the formal definition of startup, but for me, if I see any company who's still there's a burn rate or working on funding, right? It's a startup because, like you said, it's backed by funding. You never know when it's going to get dry.
So these are some companies that we can target for the profiles that we just discussed.
Yeah.
And they're actively hiring right now. So any fresher who's watching, if they want to apply, they can apply to these companies.
Yeah, they can apply to these companies. They can just Google what are the conventional vehicle manufacturers. Go to their career page and apply, right? Like,
and which job profile is actually the most in demand right now for EVs?
So the what we have seen, the firmware engineers and software engineers are mostly in demand, right?
Okay.
So software engineers, we didn't touch on the software engineer profile. So software engineers are required to work on the app part, the cloud part, right? How it communicates with the car and all those things. Those software engineers have to work. So that is really in demand right now. Firmware engineers are in demand. And yes, the hardware engineers are also there, right?
Okay.
So because, in fields like software and firmware, you need more manpower.
And what about the mechanical and electrical space, like software engineers, firmware engineers? I understand even electrical people can go there, but what about the core profiles for mechanical and electrical? Like you mentioned, battery people are there, right?
Yes.
Then powertrain people are there.
Yes.
So among these, like, which one is the most in demand?
So for battery, there's a lot of demand for the packaging engineers, design engineers, so that they can design batteries which are safe. For the other subsystems, let's say electronics part, a lot of hardware engineers are in demand, power electronic engineers are in demand. And like I said, firmware and software engineers are always in demand, right?
So I also wanted to discuss this with you, like companies like Mercedes, right? So Mercedes, based on what I've heard, you can clear it out. The design part of the car, it does not actually happen in India, right? It is outsourced, or it happens in Germany.
Right.
And some parts of whatever happens in Mercedes happens in India. So is it similar with the other companies also that we have, like Ola, Ather, or maybe Mahindra, MG Hector, right? So what all job profiles are abundantly looked out for in India, and how much of it is outsourced among the profiles that we discussed?
Right. So the reason why I suggested the audience to go for startups initially in their career, because these company startups, the made in India startups, they build these subsystems in our country from scratch.
End to end. Okay.
Even in simple, we have our own motor. Like we are, I think, Asia's, like India's first motor manufacturing we have set up in our plant, right?
Okay.
And the motor manufacturing we do in-house. We do our own battery manufacturing, BMS manufacturing, BCM manufacturing, our own HMI, right? Which you don't usually get into those exposures when you go to established companies, which rightly said outsource from abroad, right? So yeah, the startups are locally doing the things, and also a lot of government norms are pushing to do it locally. But the established companies, especially who are from other countries, are getting it outsourced. So yeah, there's a difference in that.
So among the things which you feel are outsourced right now, which profiles are prevalent in India? Like, for example, if I want to apply to a company like Mercedes, or I want to apply to a company like MG, which is again an like company from outside, what kind of profiles are they recruiting for in India? So I understand service is something which will be prevalent throughout. But what about the actual technical profiles which we spoke about?
So one thing which every company, irrespective its technologies in India or abroad, will be looked after. See, whatever technology you develop, let's say in Europe, you need to validate in India that whether it works for its temperature, whether it works for its road vibration or not.
Right.
So you need some engineers who can test and validate it. So testing and validation engineers is being sought by all the companies, irrespective of where their technology is developed in India. So one profile we just are now touching on, that testing and validation engineer, where it tests and validates for the regulation of India, for the roads of India, right? And other profile, which is also sought by all the companies, is the application engineer, to validate that on application level whether our product is okay or not, right?
Okay.
A car which is running 200 kilometers in Europe may run only 100 kilometers in India.
Because of the temperature, or whatever climate.
Lot of traffic. In Bangalore, I don't know how much it will run.
Right.
Or, even the potholes, or, the road conditions and all.
Correct.
So, yeah. So these testing, validation and application engineer, these two are sought by most of the companies. So, like I'll just suggest to audience, whenever they look for the profiles. Don't just stick to a particular profile. You have to just be a design engineer. You can start with a testing validation engineer, go to design tomorrow, because all of these are interrelated, and exposure to each field will help. Right. I worked as a testing engineer also. I worked as a design engineer also. So one should not limit himself while looking for profile, and just go through the internet. All the companies are working on EV, whether Indian startup or established. Go to Mercedes, BMW, or whatever their sites. Apply on the jobs and try to enter this technology, learn this technology. That's my suggestion to everyone.
All right. So thank you, Bhanu, so much.
Yeah.
Right. And it was lovely talking to you.
Same here.
And I think a lot of people would have gotten clarity into, how they can get into EV. Right. I'm sure they cannot mimic your journey because it is very organic. But I think Bhanu shared a lot of points for us where we can understand if today I want to get into the EV space, how I can get into the EV space. So thank you so much, Bhanu, for that.
Thank you, man.
And there are a lot of things which we did not discuss. So obviously there should be a part 2, and we'll request Bhanu if he has time in the future, he can give to us and we can talk more on this topic.
Sure. Thanks a lot.
So thank you, Bhanu.
Thank you.